Hi there everyone. Today we're going to have a look at solving inequalities. So, for all of these questions you're going to be asked to solve the inequality. So instead of writing that 4 individual times, I've just put it at the top. Now in the simplest form you're going to look like question number 1 here. Solve for x when 3x's are less than 12. Well, we're going to treat that just like a normal equation. We're going to divide by 3 to both sides and we get 4. Pretty straightforward. Now, you may be asked to draw that on a number line. So if there's 4, there's 5, there's 3, what we do to represent this symbol is an empty circle. You'll see that that will change on future ones. And where are all the numbers less than 4? Well, they're this way. This is a one-step equation, but instead of an equation, it's an inequation. That doesn't sound right, so we just call it an inequality. So we're going to do the same thing. The x's are on the left, this number term needs to be on the right, so I subtract 2 from both sides, then divide by 5 like you would to solve a normal inequality. Now for this one, if there's 5, there's 6, there's 7, there's 4, we're going to draw a circle on 5, but this time we're going to colour it in, and that shows us that we can include it, and that's where the numbers are bigger than 5. Division, nothing to worry about. So let's call that one 2, let's call this one number 3. We're going to times by 3 to both sides, giving us with x is less than 15. And this one is a two-step equation, so number 4, two-step equation. And there's x's on both sides, but if you look, this has the least, and it's a minus 2x. So don't fall into that trap, we need to add 2x to both sides. So if I'm going to get the x's on this side, and I'm going to get the number terms on this side, so there's two number terms. This one's in the right place. This one's got to go, so I'm going to take away 2 to both sides, and I get to there. If you need to take an extra step to get to that stage, it's fine, but at GCSE you want to really start thinking about combining those. So divide by 8, and there we go. Let's have a look at some harder ones. So they may ask you the similar question, but ask you to find the largest or the smallest possible integer, and that depends on the question. They're not going to say find the largest and the smallest, because you'll see in a minute that won't make any sense. So if we solve this first one here, we're going to subtract 4 to both sides, and we get to this. Right, and now we've got some non-friendlies. So that's just going to be 8 over 3. Now if you think about this as a number line, that is 2 2/3. So we're going to have 2, we're going to have 3, we're going to have 1, we're going to have 0, we're going to have 4 at the other end. But 8/3 or 2 2/3 is about there. So what is the largest it could be? It could be 0, it could be 1, it could be 2, but it can't be 3 because it has to be less than this value. So the largest it can be is 2. They're not going to ask you the smallest because there's an infinite amount of small numbers there. So this one would be what is the largest integer that satisfies this inequality at the top there. Okay, 2 steps. So let's get the x's on the left because that's where the most of them are. That means we need to get rid of this minus 3 by adding 3. And we get to 14. Again, not nice numbers. Just think about it. Well, 3 times 4 is 12, so that's 4 2/3. So there's 4, there's 5, there's 6. 4 2/3 is about here, and it's bigger than that. So what is the smallest number this could be? It could be a 5. And I just mentioned this now, if this was an equal sign, it wouldn't make any difference because it can't equal that because we're looking for integers, which means whole numbers. Let's keep going. Right, these look easy, but these are the sneaky ones. When you have a negative amount of x's, that is really sneaky. Because, and actually, I would always try to avoid it. I'll show you what I mean on this next one over here. But I'm going to divide by 3, sorry, minus 3 to both sides. Now, what has to happen here? Let's have a look at some numbers. Well, I'll tell you, the sign has to change direction. So now it means x is greater than minus 4. And I'm really sorry for my awful handwriting, but it's not easy on this software and I need to get used to it. I'm not even going to explain that because of the length of the video, but if you're going to divide by a negative, you always have to swap the sign. Now, for this one, we've got a one-step equation. So we've got x's on one side, but it's actually a minus. So in fact, on the right hand side here, where we've got 0 x's, that's actually got the most x's. So we would naturally collect them on the right hand side. So I'm going to add 3x to both sides. And because I'm collecting the x's here, this number term here, the 2, that's got to go. So subtract 2 to both sides. Divide by 3. And that upsets me that way around. So I'm going to pop them the other way. So I have to change the sign. If you think about it, if there was a 7 here, 2 is less than or equal to 7, that makes sense. But 7 has to be more than or equal to 2. So when I swap the sides, I have to change the sign. So dividing by negatives, don't get caught out. And if this x is a negative, always make it positive. If, however, you decided to go a different route and subtracted 8 from both sides, you'd end up with that. When you divide by the negative 3, you'd get the 2, because a minus divided by minus is a positive. Just remember, you need to change the sign when you divide by negative. Okay, so compound inequalities, these are a bit harder, especially the second one, but you can do the first one much easier way than you can the second. So I'll do this one first, and most of the time you're going to get questions like this. So 2x plus 3 is less than 19, but it's also more than 1. So what I can do is, oh, don't know what happened there, is if I take away 3 to, normally say what's happening? We say take away 3 to both sides, but in fact, there's 3 sides now, because these are called inequalities. It's like an equals, but just not equal. So I would end up with 2x is less than 16. What is happening? Sorry, guys. And minus 2. Now I could divide by 2 to every single part of this, and I would end up with x is less than 8, but more than minus 1. I could draw that on a number line, something like this, and it's all the values in between there. Let's just change this for this lesson. If I changed it to less than or equal to, I colour it in. It's as simple as that. Wow, this one looks way harder, doesn't it? And it is. And if you do what we've just done, it really doesn't like it. So what I'm going to do is I'm going to split these and solve them in pairs, and you'll see what happens. Something pretty neat happens. So if we, in fact, I'll write out this first one. Okay, so here I would collect the x's on the right hand side, because that's where the most is. So take away 2x to both sides. And because the x is on the right hand side, this 3 needs to go, so I'm going to subtract 3 to both sides. And I end up with, if I divide by 2, this is my answer. Okay, let's do this one as well, this pair. So I've got 4x plus 3 is less than 3x plus 10. So x is this time on here. I subtract 3x to both sides. This 3 has got to go, this constant term, so subtract 3, and I get 7. Right. So what you can do is now you can, instead of splitting them up, you can put them back together, and you'll see that x is in the middle of both, and we get ourselves a nice compound inequality. On a number line, that would go from minus 2 to 7, not inclusive, inclusive, and all the values in between. One last thing. So we might give you 2 at the same time. So find the set of values of x which satisfy not only this one, but also this one. So we have a bracket here, so let's expand that. So we've got 3x minus 6 is greater than x minus 4. Solve it as normal, so x is on one side, I'm going to add 6 to both sides as well, and I get x is greater than 1. If we do the one on the right, there's the most x's on the left, so let's collect them there. Number term needs to go, and I end up with this. So what does this look like on a number line? So I've got, put 0, 1, 2, and 3. So x has to be greater than 1, And because this is a different inequality, I'm not going to put it on the same level, but this has to be greater than 2.5. So I'm going to put it there. So where does it work for both of these inequalities as soon as there's an overlap? So where's this overlap happen? All values greater than 5/2. So if there's 2, just draw them on a number line and look for where they overlap. I think that's it. Yes, it is. Right, so best of luck, guys.